Good day guys, and welcome to this video. In today's lecture, we are going to be discussing the concept of surds from the very beginning, and we're going to continue this series until we get to the very end and then solve some practice questions on surd. If this is your first time coming across my videos, I please urge you to like the video, save it because you are most definitely going to need it next time. And if you have students that are in any of the senior secondary school classes that are hoping to write their final year exam for secondary school classes, you can as well forward this video to them because it's going to help them a lot. Now, let's get right into the concept very quickly. The concept today is surd. But before I even explain this topic, I would like to bring our attention back to something. Now, whenever you are asked to take the square root of a number, what are we asking you to do? Whenever we're asking you to take the square root of a number, what we are asking you to do is to look for or to give us two numbers that multiplies to give us x. So when I say give me the square root of 1, what I'm asking you to do here is give me two numbers that multiplies to give me 1, the same number. So in this case, you know that 1 times 1 is going to be 1, right? So we say the square root of 1 is 1. If I give you the square root of 2 and I tell you, give me the square root of 2, what I'm asking you to do here is to look for two numbers, the same numbers, that multiplies to give me 2, right? So if you have 2 times 2, this gives me 4, right? There is no number you multiply to give you 2, right? So we say 2 is not a perfect square. Are you understanding the concept? If I give you the square root of 3 and I say evaluate the square root of 3, that is, give me the square root of 3. What I'm asking you to do is look for two numbers that multiplies to give you 3. The same numbers that multiplies themselves together to give you 3. And you know that's not possible. There's no number that gives you 3, right? There's no number, the same number you multiply together that gives you 3. 3 also is not a perfect square. And then, if I give you the square root of 4 and I say evaluate the square root of 4, what I'm asking you to do is look for the same numbers that multiplies themselves together to give me 4. And those numbers are 2 and 2. So 2 and 2 is going to give me 4. Therefore, the square root of 4 is just going to be 2. Because if you multiply 2 in two places, that is, this number multiplies itself, it's going to give you 4. So the concept behind surd is that any number that is not a perfect square, or the square root of any number that is not a perfect square, is a surd. Do you understand the concept? Note that the square root of any number that is not a perfect square is considered a surd. So when I give you, for instance, when I give you this is not a perfect square, right? There's no number that multiply to give you 2. So 2 is a surd. If I give you this is also a surd. If I give you this, you can't say this is a surd because 4 is a perfect square. So we say this is the square root of 4. And the square root of 4 is 2, right? So when the number is a perfect square, it's not a surd. More examples. If I give you the square root of 16, this is not a surd because this number is a perfect square. So we say square root of 16 and that's 4. If I give you the square root of 64, this is not a surd, provided that this number inside here is a perfect square, right? There are two numbers that multiply to give me 64, and those numbers roots are 8 and 8. So I have 8 as the square root. So these numbers are perfect squares. Right? But when I have something of this nature, square root of 2, square root of 3, square root of 5, square root of 7, square root of let's say 11, all these numbers, they are all surds. Right? Now, having understood the concept behind surd, we know what a surd is. We can also say that a surd is an irrational number. We have rational numbers and we have irrational numbers. So irrational numbers are numbers that have lots of decimal points, lots of decimal numbers behind the point. Right? Lots of decimal numbers behind the point. Something like 2.33333. This is an irrational number. So numbers that have much or many decimal numbers behind the point, they have lots of numbers behind this point here. These numbers are considered irrational. Right? So let's prove it. Let's say we have, if I give you surd 2, I can't call this square root of 2 now because this number is in a perfect square. So this is surd 2. So surd 2, if you punch surd 2 on your calculator, you'll be having 1.414213562. You see, it continues going. So this number is irrational. Right? If you have surd 3, if you punch surd 3, because it's not a perfect square, you will have, so if you have surd 3, if you punch surd 3, you have 1.732. You see, we have lots of decimal numbers behind the point. So when we are dealing with surd, we are dealing with a square root of a number that is not a perfect square. I believe you understand the concept. If you also punch surd 7 on your calculator, because 7 is not a perfect square, so we can't call it square root of 7. We say surd 7. So surd 7 there is going to give you 2.6457. It continues like that. So they are all irrational numbers. Right? So just like we have rules of addition, we have rules of subtraction. When we're doing indices, we have rules of indices, standard form. Surd also has its own rules. Right? You know, one thing with mathematics is mathematics deals on principles. We have principles for each operation in mathematics. Do you understand? So now we're going to be giving you the laws of surd, that is the rules guiding surd, that is how to answer questions on surd. And trust me, we'll be doing lots of examples under each of these laws. Do you understand? Now, but first of all, before I give you the laws, I want to explain something. My own students in my space, I teach them something whenever they want to add fractions, and I think I should explain that here. Now, I told my student that whenever you want to add a fraction, whenever you want to add or subtract a fraction, you have to consider two things. You have to consider two things. One, you have to consider if the fraction is a like fraction and if the fraction is an unlike fraction. Do you understand? Now, let's say I give you a fraction. Sorry, I'm digressing a bit. I want you to understand the concept because I'm going to use that to explain the first law of surd. When I give you something of this nature, 4 over 5 plus 3 over 5, what I taught my students is this: consider the fraction if it is like. If it is like, we are going to have the same denominators, and if it is unlike, we are going to have different denominators. For this fraction now, this fraction is a like fraction. Why? Because we have the same denominator. So what do we do here? We just add the numerator 4 plus 3, and then we pick one of the denominators since it is like, right? And we just have 7 over 5, which is same thing as one whole number 2 over 5. This is only when it is like, right? But when it is not like, let's say you have 4 over 5 plus 2 over 3. In this case, the fraction is not like. What do you do here? What you do is you either find the LCM or you cross multiply it. What do I mean? You cross it. This leading diagonal, 4 and 3, you're going to multiply them first. That is, 4 times 3 is going to give you 12. Then plus, then 5 times 2 is going to give you 10, then divided by 5 times 3 is going to give you 15, right? And when you add this 10 plus 12, you're having 22 all over 15. So this is the fastest way, right? Now for the first law of surd, the first law of surd says that when you have surd A plus surd B, you are not free. It is not equal to the group surd of A plus B. In other words, you can say that when you have surd A plus B, it is not also equal to surd A plus surd B. So for example, if I give you surd 3 plus 2, the law is saying you are not free, or it is not equal to you splitting the surd. That is, you saying surd 3 plus surd 2. It is not possible. Do you understand? So you can only add what is inside the surd. So you can only have this one now. This surd 3 plus 2 is just equal to surd 5. It's not equal to you splitting the surd. That's the law. That's the first law. Do you understand? Then the second law of surd states that when you have surd A multiplied by B, the law states that it is equal, or you are free to split the surd, provided that the sign is a multiplication sign. So you are free to split the surd. You have surd A multiplied by surd B. In other words, we can say that the surd of A multiplied by the surd of B, we can group them together as surd A multiplied by B. So for example, when you have surd 3 multiplied by surd 2, we are free to group them together provided the sign in the middle is a multiplication sign. So this is going to be surd 3 multiplied by 2. And when you multiply this, is going to give you surd 6. Are you seeing that? Alright. Then for the third law of surd, the law states that when you have surd A over B, this is division now, right? This division sign in the middle. We are free to split both of them. So we're having surd A all over surd B. And for example, when you have surd 3 over 2, we are free to split the surd because of the law. So we split the numerator and the denominator. So we're having surd 3 divided by surd 2, right? So these are the 3 basic laws, right? There are other deeper laws that we're going to discuss about while we continue this series. Alright, let's look at these sample questions. We are asked to simplify the following surds. For question A, we are given that surd 3 plus 2 surd 3 plus 5 surd 2 plus surd 2. We are asked to simplify that problem. Let's have the solution. For question 1, we are told that surd 3 plus 2 surd 3 plus 5 surd 2 plus surd 2. In this case, we are going to consider something. You know, I brought up the issue of like fractions, right? We said like fractions are fractions with the same denominators. So what you want to consider before solving questions like this, since it is plus and minus, because I told you that whenever you want to add a fraction or subtract a fraction, you consider the denominators, right? That will tell you how you continue further. In this question, whenever you want to add or subtract a surd, you consider if the surd is like or if the surd is unlike. So what we have to do here is we have to collect like terms. We collect like terms. So what are the like terms here? The like terms here, we look for what has surd 3 inside. So this one has a 3 inside, this one has a 3 inside, so they are like. This one has a 2 inside, this one has a 2 inside, so they are also like as well, right? So when you are adding or subtracting, you check if the fraction is like. So you collect the like surds together, and for a surd to be like, the number inside the surd must be the same. So for these two now, they are like, so I'm going to add them directly. Of course, you know that there is a coefficient of 1 here, so I'm going to add these two surds. So 1 plus 2 is going to give me 3, so I'm having 3 then surd 3 for these two, right? There's a 1 here, so that 1 plus these two outside. So what is outside is going to add what's outside, so I have 3, and then I pick one of the surds, so I have 3 surd 3. Then for this one, I'm having surd 2, they are also like. So this is 5 plus, there is a coefficient of 1 here, so 5 plus that 1 is going to give me 6 surd 2. Now you observe that they are unlike surds. This has 3 inside, this has 2 inside. I can't continue adding further. Besides, I cannot even say 3 plus 6, it's not done. I cannot add the coefficient since the surds are different, so I leave my answer in this form. And then for question 2, we are given 4 surd 3 plus 2 surd 5 plus surd 3 minus 2 surd 5 plus surd 5. If you observe, we collect like terms. What has 2, 3 and 5? So we don't have surd 2 inside, we have surd 3 and surd 5. So I'm collecting that. So I'm having 4 surd 3. So 4 surd 3. Which other one has surd 3 here? This has surd 3. So I'm having 4 surd 3 and then plus surd 3. Then surd 5 now plus 2 surd 5. 2 surd 5 minus 2 surd 5. Then plus surd 5. If you notice, I collected what has the same surd together. This surd 3, this surd 3, I brought them together. Then 2 surd 5, then minus 2 surd 5 plus surd 5, I brought them together as well. So for this one now, this is going to be 4 plus 1. That's going to give me 5 surd 3. That's for these two. Then all these ones are like, because they have surd 5, surd 5, surd 5 is common, right? So I'm just adding the coefficient, and then 2 minus 2 is 0, so this is gone, and 0 plus 1 is 1, so I'm having plus 1 surd 5. Of course, I didn't write 1 here because 1 is very minute in mathematics. And of course, you know I can't add these two surds together because they are alike. This is 3 and this is 5. They are alike surds, so I leave my answer in this form. Thank you for watching, and see you on the next one.